Hi, I'm an old guy and I do maths. We have a neat little problem here which is going to take us through a few areas of mathematics, principally circular trigonometry, but we start out by using the skills that you learned when you were solving quadratics. So, if x lies between 0 and 2 pi, find all solutions for this equation. Root 2 minus 2 sine x times 2 cos x minus root 3 equals 0. Well, those of you familiar with quadratics know that in order to make this equal 0, we make this, or both of them equal 0. So, let's set about doing the left-hand side. Root 2 minus 2 sine x equals 0. A little bit of manipulation here. Negative 2 sine x is going to equal negative root 2. And so sine x is going to equal negative root 2 on negative 2, which is going to give us root 2 on 2, which is the rationalized form of 1 on root 2. I'll just demonstrate that up here. 1 on root 2 times root 2 on root 2 gives us root 2 on 2. This is the form in which we can find the value of the sine of x in degrees or radians. And to do that, we use one of these triangles that you may or may not be familiar with, but if you do this for very long, you'll get very familiar with it. That's 45 degrees and that's 45 degrees because that's 90 and these two sides are the same length. So this is equal to 45 degrees or pi on 4. Right. That's going to be one of our solutions. Pi on 4 is going to make this equal 0. But we have to look between 0 and 2 pi. And for those purposes, what I've done is I've got out one of my old textbooks, which you can see I've written in. And we'll just have a quick look at this. Now, all sines, cosines, and tangents are positive here. We know what we're looking for. We're looking for pi on 4. So that's 45 degrees off the x-axis. So I'm working in this quadrant. As I said, all sines, cosines, and tangents are positive here. Sines are positive here. We work off the x-axis, 45 degrees, or pi on 4, we get that. That's there. We do the same thing over here. We work off the x-axis, so pi minus pi on 4, yes, gives us 3 pi on 4. That's the other solution. Now, mathematically, what this looks like is we have our one solution here, pi on 4, and I'll just zoom back in. So we have our one solution there, pi on 4, and then we have pi minus pi on 4, which gives us 3 pi on 4. Now, that is the second solution. If I just draw an arrow for that. Now, we're going to deal with this. 2 cos x minus root 3 equals 0. Give ourselves some space. Rearrange this. 2 cos x equals root 3. Cos x equals root 3 on 2. Now for this, we need another triangle. And mercifully, this did not have its denominator rationalized, I imagine, because the triangle we're going to use is this. That's root 3 and that's 2. Now, we know that this is 60 degrees because this was originally an equilateral triangle, 2, 2, and 2. This angle is 60, so this angle must be 30, or pi on 6. So we need to know where we have pi on 6 in our scheme of things. So let's have a look. We'll get this out again. And you'll see that pi on 6 is here, 30 degrees. And this is where it's positive. And then in another part, so we saw it positive there. Now, in another part of the unit circle, cosines are positive, and this is 30 degrees off the x-axis. So it is 2 pi minus pi on 6 in this case, and it's 11 pi on 6. And so we have our second solution. Just let me bring that in again. So 2 pi minus pi on 6 is going to equal 11 pi on 6. And our first answer was pi on 6. So our answers are, the solutions for this are pi on 6, then pi on 4, then 3 pi on 4, and then 11 pi on 6. Those are the values of pi, or the angles that will make these cosines, or the cosine and the sine, in these brackets, render these brackets to 0. That's the answer. Thank you very much for watching. I hope you found this useful. If you did, please like and subscribe, and I'll see you next time. Bye.